Hello everyone. In this video we are going to solve this very difficult looking question. So let us begin. Before I am going to give you the solution, pause the video and give it a try. So I think you have tried it. So let's move to the question. The question says a uniform metal chain of mass m and length l, and the length is l. This is the chain whose the entire length is l, and its mass is m. Now it is released from rest. That means now it is released from rest, so it will fall down with certain acceleration. Okay, it is released from rest with a part of its length l, small l. This is small l is hanging on one side when it is released from rest, and the length capital L minus this small l is hanging on the other side. Okay, at a certain point of time, when this l becomes when this l will become when this at this certain point of time, when this small l will become capital L by x, then at that point of time the acceleration is going to be g by 2, that is half of gravitational acceleration due to gravity on earth. Okay, so we have to find the value of x. Is it 6? Is it 2? Is it 1.5? Is it 4? Okay, so now let us begin to solve this question. What we will do, first of all, we will calculate the mass of this L length of chain. Then we will calculate the mass of this L minus small l length of the chain. Then we will find the acceleration at the point of time when this is small l will become L by x. Okay, so let us begin on a new page. The question is very clear, I think so. Okay, now the mass of this length, I'm writing here, the mass of this L length is going to be, since the mass is uniformly distributed, so the mass of one unit of the chain, the mass of L length of chain is m, so the mass of one unit length of chain would be capital M by capital L. So this is the mass, unit mass of the chain. Now for the mass of L length of chain, I will multiply this with L. Okay, now I am going to calculate the mass of the other part of the chain that is hanging on the other side. So the mass of this capital L minus this length is going to be m, capital M by L times capital L minus small l. So this is the mass of this is the mass of the other half. This is the mass of this portion of the chain. Now I have to calculate the acceleration for this. Now I consider when L will become is capital L by x, then this will become what? This will become m by L times, instead of small l I can write L is capital L by x, so this will come out to be capital M by x. So this is the mass of this portion of chain. Now I want to calculate the mass of the other portion of chain, that is the mass of this. It is going to be m by L times L minus, what is this small l, I can replace it with L minus x. Now I will take this capital L common and cut it out. Okay, so I'm left with 1 minus 1 by x, that is going to be m times x minus 1 this is going to be the mass of the other half. Okay, now I have to calculate the acceleration. Okay, so for the acceleration, so I will draw the FBD of this chain. Look it carefully. Okay, so you know that this mass will be exerting some force that is equal to mg weight, and this will be exerting force that is equal to some other m dash g. So that I have calculated the mass. So the force exerted by this portion of chain in the downward direction is going to be mass. What is its mass? Its mass is what? The mass of this portion of chain is L minus capital L minus small n portion is going to be this. So I'll write m by x times x minus 1 times g, that is the mass of this. And now this will also fall with some acceleration, and it has a mass of m by x times g. Okay, now the acceleration is going to be f net by m net, total mass. Now what is f net? Find the value of f net. What is going to be f net? So f net is going to be, f net is the force. Now stretch the chain like this. What I'm saying, stretch the chain like this. So it has a force of here, what? M by x times g, and a force of here that is equal to m by x times x minus 1 times g. So now the f net, is going to be, I'm writing on the other page. So f net is going to be what it is going to be, this mass, since the acceleration is in this direction. So this mass minus this mass is going to be f net. So f net is going to be, what is the mass of the L minus capital L minus small l, that is m by x times, so m by x times x minus 1 times g minus m by x times g. This is the mass. Okay, this is f net, and this mass must be equal to what? Total mass m net into acceleration. So acceleration we have to find. Now I will simplify this complex looking by taking m by x times g common. So I am left with x minus 1 minus, I have taken only plus m by x g common, so minus 1. Is it clear? That is going to be equal to m net is what? Total mass, that is capital M, times acceleration, which we have to find. And this acceleration is given in the question. If you look at the question, the acceleration is given to you as g by 2 at the point when this small l will become capital L by x. So I will in place of a, I will write g by 2. Now from this equation I have to find the value of x. That is going to be very simple, very easy. You can solve it. So let us proceed further. So this m will cancel this m, this g will cancel this g. So 2 will come this side, x will go that side. So it is 2 times L minus 2 going to be equal to x, as I think so. Yeah, x only. So now 2x minus 4 is going to be equal to x. 2x minus 4 is going to be equal to x. So now this x will come this side and it will become x is going to be 4. X is going to be 4. So x is going to be 4. D is your correct answer. Here you can see the here you can see the solution. What we have did, let me summarize it. First, I have calculated the mass of this and this portion by using the unit mass to be m by L, and then I have calculated the F net by drawing the FBD. This is the FBD. So by drawing the FBD, I have calculated the F net, that is going to be equal to total force times acceleration. What is total mass? Total mass. So what is total mass? It is capital M. Acceleration is g by 2. Keep the value in this equation. You will evaluate the value of x, that is going to be 4. So this is our solution. Thank you and have a wonderful day. Thank you everyone.